Okay, all right, good morning. It's such an honor to be here in Sophie today, especially because it was quite spontaneous to be here on stage. So I don't have quite the hot take, but this talk is about HTML-aware ERB, or how I say the path to reactive rendering. Or if you want to make this a hot take kind of slides, we could also say why I believe that Hotwire isn't enough and why I think we should try to build something more ambitious, that we want to have more advanced tools, have more advanced tooling that we can build more ambitious applications. So yeah, my name is Marco, and I've been trying to push the boundaries of what's possible with real-time server-side rendered web applications and using the HTML-aware approach. For the last few years, I've been on a mission to improve the developer tooling and the developer experience in the Hotwire ecosystem, and more recently in the Rails view layer. So most of the time, we are using ERB, which stands for Embedded Ruby. But the thing is that ERB itself is really versatile. Most of the times in our day-to-day lives, we are using ERB next to HTML. So we are dealing with the variant of HTML ERB. So this talk is kind of a continuation of my talks from RubyKaigi, RailsConf, and Rails World last year. And at RubyKaigi last year, I was talking about this HTML-aware tooling. And there, I was talking about HTML ERB and how this kind of came to be the ERB project. So that's kind of the name. And ERB itself is, in the heart of it, is a parser. And at RubyKaigi, we shipped this parser to be the foundation for all of this tooling. And it shipped for Node.js, RubyGems, WebAssembly, and it's also written in C. And in the meantime, it became to be this whole tool chain for HTML ERB files. But on this same talk, I also talked about this point here, where it says that we want to try to build a potential new engine for rendering reactive HTML ERB. So that's what I want to talk about today, kind of how we want to build this engine and what it takes to get there. So this is the path to reactive rendering. And for this, we want to talk about what reactivity is, how ERB engines work, and what's still missing today. So the idea is that we want to look at what Hotwire is, how it's good, what it's already doing well, and then try to kind of get inspiration from previous frameworks, or from frameworks from other kind of languages, and bring those ideas back to Ruby. So given we have like a template, and we have some states, we want to track what's kind of happening in our states, and whenever state changes, we try to re-render only the pieces that actually changed, and then actually update the client side to patch the page to reflect these changes. So you want to be just rendering what's actually changing. And for this to work, we need to kind of have a few things to make this happen. So I want to talk a bit about ERB and how this kind of makes it possible. So the thing is that Rails just works, and it kind of keeps working. An app you wrote a few years ago can be upgraded to the latest version, and you don't have to rewrite the whole app. The patterns are stable, the conventions are stable, and that stability is kind of a feature, not a bug. And it's also why people keep building businesses on Ruby and Rails. But the question is kind of, or the challenge is, how do we keep innovating without breaking all these existing kind of patterns that makes Rails innovate really good today? And more recently, we also saw this new wave of Ruby developer experience improvements. I borrowed this slide from Stan Lowe, where he was kind of showing this timeline of all the recent advancements in the Ruby developer experience. And you can also see on this slide how Prism, the parser, the new Ruby parser, is kind of the foundation of all of this. So Prism is powering all these new tools and these new ways of tools. But there has been this one spot where we didn't really innovate yet much, and that's the view layer itself. And I've been asking myself why there never was any tooling for that. And I feel like the reason is that there was nothing to build against. There was not really a parser like we have with Prism for Ruby now that could handle HTML ERB really well. So the question is, what becomes possible when we kind of teach our ERB engine and the ERB runtime to also understand HTML itself? And what if we established a more formal HTML ERB grammar to kind of handle what is valid and what is invalid? So a formal syntax to define what's valid and what's invalid. So we can provide structure, we can provide hierarchy, we have this HTML awareness. So our tools can reason about the structure and the hierarchy of these documents. And this all became possible because the Ruby Prism parser is a thing now. So in combination, we can take our new herb parser to kind of detect the HTML ERB structure. We can take our Prism parser to kind of check the Ruby grammar. And that gives us pretty much a full validation before we even try to run our code. If you have a missing end tag, both herb and Prism can catch that. If you have invalid Ruby syntax, Prism can catch that. And if you have unclosed HTML tags, herb can catch this too. And establishing this grammar is kind of what makes all these tools now possible. So that's kind of what herb is. It gives us two things that didn't really exist before. It defines the syntax, kind of how these rules for HTML and ERB, how they interleave, how they nest, and how they relate to each other. It defines a grammar for what HTML ERB structure looks like, what is allowed and what isn't, and what the engine can count on when you try to run the code. And with a syntax and a grammar, you can build a parser, and on top of a parser, you can build this full tool chain for HTML ERB. And I think this is what was missing. Not just the tools itself, but also the language definition, the grammar, to build these tools on top of. So we have one parser, which means we have kind of one truth. And no matter where you try to run this parser now, be it in your editor, in your CLI, or in your app using the engine, you have the same errors, you have the same syntax tree, and you have the same rules. So they can all build on the same foundation. And this is really powerful. If your editor tells you there is an error, you can be sure that there is an error, and you don't have to run the code to find out that there's something wrong about it. Because again, it's all powered by the same underlying architecture. So we have been building a language server that you can use in your editor, and it will give you this instant feedback about invalid HTML, about missing closing tags, missing syntax or wrong syntax, and also wrong Ruby syntax if you are missing some Ruby syntax in your ERB tags. And the language server itself has all these other features, including the agnostics, the linter, the formatter, and a lot of more stuff I can't really talk about today, but it's pretty much a full-featured language server for HTML ERB. Okay, so this is kind of the tooling, the static sides. So let's switch over to the runtime to kind of render ERB documents. So ERB templates are Ruby, or well, they are almost Ruby, because for us to be able to run them, we need to convert the ERB to Ruby first. So this typically means that we have to take our ERB templates, pass them through the engine or the compiler, which gives us Ruby code we can run on our Ruby environment. And the most typical engine that we use today, which also Rails uses today, is ERB engine. And I want to walk you through how ERB engine compiles this code. So let's take a look at this example here. ERB uses a regex to split up this template into multiple pieces, namely the static and the dynamic pieces. You can think of those as like strings and dynamic content. And what we can do now is kind of go over each of those elements and call add text or add expression to kind of handle these individual parts of our templates. And if we do this, we get this sequence of instructions, which then compiles to a Ruby string, which looks a bit like this. So you instantiate a buffer, you shovel these static parts into the buffer, or you render the dynamic pieces and shuffle them into the buffer too. And at the very end, you call toString on it to kind of get the string back from this render operation. And this is designed to be evaled, so whenever you eval, you get the result back. And that's kind of the rendered string as an output. And that's kind of how we take our templates, compile it, and then be able to run it and render our templates. But you might have also noticed that there is a syntax error in this template, and our engine didn't complain about it at all. So it just happily compiled it because it doesn't know about HTML itself. So we want to make our engine aware of HTML so we can build all these advanced features on top of it, including the reactivity. And that's kind of what we need to enable that. So we want to turn our ERB engine into a HTML ERB engine, or to say it differently, we want to take it from string templating to HTML templating. And that's kind of what Herb Engine gives us. So Herb Engine is a implementation that is like ERB engine. It's API compatible, but with the difference that's built on top of the Herb parser, and it can give you the errors when you have invalid syntax. So it doesn't even let you compile the template if there are syntax errors in your template, which makes this an HTML-aware ERB rendering engine. It's API compatible. So when you take this template again, this time including the closing tag, we can parse this template using Herb. So Herb can parse this template, and it will give us this syntax tree as a result. I will zoom in on this so you can see it better, but the idea is that we have a document, there's an HTML element node inside of it, it has an open tag, it has the body with all its contents, and there's a close tag to close the element off. And Herb allows us to implement visitors to kind of visit all these nodes in sequence and in this tree structure. And that allows us to build us a compiler which can compile our syntax tree to a Ruby script that we can run like we saw earlier. So we can go through each of those nodes. For the HTML open tag node, we can see all these parts on the right side, and we can call add text for each of those individually. For the HTML text node, it's just text, so we can just call add text for that. There's nothing more to that. And for the ERB content nodes, which are the ERB tags, we can look at the opening tag and see if it's an output tag, and if it is, call add expression, otherwise just call add code, which just appends the codes to the buffer too. So if you visit this template, we get this sequence of instructions, and if you can compare it to eRuby, you can see it's a lot more work that we have to do compared to what eRuby has to do. But what we can do now, instead of just outputting and compiling the string, the templates, we can collect these tokens and collect also their types alongside them. So when we have this sequence of instructions, we can turn them into kind of an array and have all these pieces next to the types. And you can see here that we have a bunch of consecutive types. So you can see there's a bunch of text nodes, which we can kind of collapse into a single node on a first pass, and then iterate over those and call add text and direct expression again, so we have the same output, or the same instructions. So with that kind of optimization, we have the same output for eRuby and for Herb Engine. And if you look at the compiled output, we also see it's pretty much the same for outputting and rendering this template. But with the benefits that we have, all the guarantees the parser gives us, and it ensures that we have valid HTML templates and valid syntax. And that way, we turn it from a string templating engine to a HTML templating engine. But also, with this knowledge, we can start to build more of these ambitious things. One of the first things we did was to improve the error messages in Rails' error screen, so it can exactly tell you where something went wrong in your template instead of showing this big screen which doesn't tell you where the error is. So this makes it easy to know where stuff is going wrong. And since we control the rendering with all this tooling now, we can also inject more markup in the templates in development. So what we do is we inject this dev tool in your local environments, which allows you to toggle these advanced tools. So you can toggle the outlines, and what this gives you is an outline of all your templates in your browser. You can see where templates start and where they end. We also have more colors for the different types of templates we have. So the views are blue, the components are orange, and the parsers are green. You can hover over these labels to show where they are defined in your app, so you can see the path. And you can also click on them to open exactly where they are defined in your editor, so you can go back and forth really easily between the two. The other thing we made is like these outlines for where ERB content is used to render the page. So all these purple outlines are using ERB to output the content. And similarly, if you hover over those, you can see what kind of ERB was used to produce this exact output in the browser, which makes it also super easy to debug again to see where stuff is coming from. So yeah, this is all cool, this is all the nice tooling, but where do we go from here? What else do we need? And I was asking this question kind of, how could we complete the Hotwire story to make it all more ideal and better and more ambitious, and we can build more ambitious applications? So how would it look like? And what if all these, our Ruby apps could have all these nice features that the single-page applications promise to us, like including the reactivity, the also optimistic UI updates, offline functionality, and all of these other nice feature sets they promise, without having to abandon our loved server-side rendered HTML, and without having to write these single-page applications, and without having to give up the full-stack Ruby, which we all know and love. And that's kind of where reactivity comes in. And when I talk about reactivity, I want to talk about two different things of reactivity. One is production reactivity, the other one is dev time reactivity. So let's first start with production reactivity. Kind of every major ecosystem has tackled reactivity in some way or form. JavaScript has introduced virtual DOM diffing in React, which compares the whole tree. It only patches what changed, kind of similar to what we want in Rails. Svelte has moved this whole analysis also to compile time, so you don't have all the runtime overheads. And Solid took it a step further with this fine-grained reactivity with these concept of signals. In Elixir, we got Phoenix Live View and Joseph Alim's Heeks and Live EX, which is like the ERB templates and the compiler, which allow for the compile time change tracking, slot level updates, and only sends the values down the wire what actually changed. So this is kind of the gold standard for server-side reactivity today. Similarly, in PHP, we got Livewire, which does something very similar with Blade and Blaze. But one thing they all have in common is that the engine itself understands what it's actually rendering. So it has a graph of its dependencies, which is what is allowing this fine-grained reactivity. So we need to have something like this in Ruby to build a framework like this in Ruby 2, which is something we never had. So I want to look beyond our own ecosystem, see what others do well, understand why this stuff works in other languages, and then bring it back in the Ruby way. So some of the inspiration I looked at, as I mentioned earlier, is the Stimulus Reflex, Hotwire itself, Livewire and Phoenix Live View, and all these JavaScript frameworks. And that kind of was the inspiration for this initiative to try to make reaction view possible, which is just to bring reactivity to action view itself. And the goal is what I mentioned earlier, to have these updates and kind of track what changed and only render what actually is changing and then only patch that and send it to the clients. So we want to keep what's great, we want to add what's missing, so we don't need JavaScript frameworks. And with the goal of making it all as backwards compatible as possible, so we can keep all our existing files and they just get an upgrade kind of for free. So yeah, this is what we want to build, and for order to build us, we need to understand what's in the templates. So we want to know what control flow structures you're using, what state is available in your views, and how the data flows through your app. So the missing piece for this was that we needed a parser and a grammar, which we now got thanks to Prism and her parser. So how can we make this reactivity happen now? Okay, let's look at a typical kind of request-response lifecycle. So your browser requests a server site. It wants to have a page. The server processes it and sends back pretty much a full HTML response as a result. And on the Rails side, it looks like this. So we have a route. It gives it to the profiles controller, the show action, and then renders the profiles show view. So we are kind of going through this whole stack and figuring out what we need to render. And for us to be able to know what you are trying to render, we need to understand this render graph. So if you look at our templates, which looks like this, we have these render partial calls that are rendering all the files. And luckily for us, Herb now is able to parse these calls too, and can give us the information, the important pieces to figure out what we are trying to render and what we are trying to pass along, including the name and the locals. So we can now kind of ask what files are being needed to render this profile show page. And Herb can now answer this to kind of show all these related files and show this tree of which parse is being rendered and what is kind of associated with it. You can also reverse the question and ask who is rendering this specific partial. And you can see that Herb can answer this now too, to say this partial is all reachable from these routes and from these pages, so you can see the dependencies of all of those. And since we have the understanding now of these views, we can also give you some more advanced checks, which means we can show you these unresolved render calls if you don't have enough information to figure out which files are being involved. And we can also show you the unused parsers in your app because we couldn't find a call site for them, so you might be able to remove those as a result. The next thing we want to look at is state dependencies and kind of know what we are rendering. So in a way, ERB is surprisingly well suited for this because every ERB tag has a simple contract. So if you look at this template here, and we kind of mingle it up a bit to compare it to its compiled output, you can see that the items, each line is pretty much translated one-to-one to the right side. So for these output tags without the equal sign, we just pretty much translate it to the other side. But for the output tags with the equal sign, we prepend this underscore buff, the shovel operator, and call toString on it. So we can say whenever we are rendering a ERB tag, we are returning a string as a result. And in the end, we don't really care about what's inside of the tag. We just care about it's returning a string to us. So it takes some state in, and it produces some string as an output. So when you render a ERB template as well, you also get a string as a result, because that's what you are rendering. You are rendering an HTML string of your templates. And these two basic principles are what allowing us to build this reactivity. Which also brings us to the next challenge, which is we need to know about the local variables, about the helpers, and so on. So in this template here, we have a few references, including user, link to, user path, and we don't know, are those locals, are those path helpers, are those helpers coming from your app or from action view. And again, luckily for us, Prism helps us here, so we can kind of analyze our app, use Prism to find all the locals, see the instance variables we are using, and also know about these app helpers we have in our app helpers folder. But for the action view helpers itself, we needed to build something else, which is this registry. So we wanted to have a registry to know about all the helpers and how they look like, what the signatures are, so we can take all our references, kind of subtract all the strict locals, subtract all the path helpers, and all these other helpers. And what we get as a result is ideally nothing. But if we have something which we just have left over, we just call them unresolved references. So this is kind of an approximation. It's not perfect. But for reactivity to work, we need to kind of understand what each of these calls are doing. But the good news is that this can be gradual. We can do this on a per route basis, so you don't have to know this all up front and migrate the whole app over. So we can just start with the pages that need more high fidelity or this high reactivity. And for these unresolved references, we can show you warnings. So Herb can now take these files, and it can show you here are the locals that are being used, here's the locals it receives from all the render calls, and here are all the helpers it's using inside the template itself. We can also show this for all templates, so we can see which states is being used and so on for all different files we have. And for everything that we couldn't figure out, we can also show you all these unresolved calls, so you can either provide them by defining strict locals, or we might be able to have a more explicit way to define that. But the beautiful thing is that we can now take our own tooling that we built to help you resolve these references to make reactivity work for you. The next challenge was action view tag helpers, which is, if you haven't seen those, like this kind of syntax. So you have tag.diff, you have link to, you have turbo frame tag. And the question that we need to ask here is, whenever post changes, what do we need to re-render? So if you look at this template again, we can see post is being used in these three places. And we learned earlier that this is our contract. If whenever we have a ERB output tag, we return the string. So if you look at our first reference, we can see it's being used here, which means we have to look at the whole tag, because it was a contract. But we also have a do end block here, so we have to look at the end, which also means we have to look at all its children. So we pretty much end up having to rerun the whole template anyway. So, which is not ideal. We just want to rerun what actually changed. But ERB is now able to also detect these tag helpers, which allows us to transform this kind of codes to the equivalent HTML ERB, which looks like this. So it can now transform this from one to the other in its representation. And if we now look at where post is being used, we see it's used in these two places for the ID and href attributes, and as the content of this A tag. And this is now much more reasonable for us to figure out what is changing and how it's changing, and only have to kind of look at these places whenever post changes, and don't have to look at the whole template to re-render it whenever it changes. And this is kind of what allows us to do this fine-grained reactivity now. As a nice side effect, if we understand this tooling, we can also show it in your editor to kind of show you how the equivalent HTML ERB looks like whenever you hover over these helpers. The last challenge was to track which reference is going to affect which DOM nodes in your browser. And for this, we need to build a reverse dependency index. What this means is, again, whenever post changes here, we want to see where post is being used. So we can see here, post is being used in these two places. But for us to be able to update that the post title change, we also need to know it's inside this h1 tag. So we need to look at both the h1 tag and the content of it to be able to update the browser. So what we built now is a index to say, here are all the post nodes that are going to affect the post variable, and here are all the nodes that are going to affect the user variable. And with that, we can kind of compute the minimum amount of changes that we need to reflect the updates in the UI. So this is where we are today. We can kind of understand all these tag helpers, these strict locals, these instance variables, and all the constants you're using in your templates. We can also understand the render graph, these state dependencies, and are being able to resolve these action view tag helpers. But that's the path to reactivity. We aren't quite there yet, so we cannot really ship anything today that's helping you ship reactivity in production. But all of this gives us a foundation now to build out this reaction view future. So we need to kind of fire those up, and then we are able to build something like Phoenix Live View, but for Ruby on the server side. And that's what I'm hoping to ship with Reaction View. And ideally, I'm able to ship something later this year with the most minimal version to just have a foundation. But that's kind of the idea. The other thing I want to talk about was this dev time reactivity. And the inspiration for that here is that you are using this locally. And if you are familiar with Vite Dev Server or Webpack Dev Server, you might have seen this before. But the idea is in local development, when you are updating files, we also want to get the changes reflected on our open browser without having to refresh the browser every time you update your files. So we don't want to have a full page reloads and re-render the page whenever you update your files locally. So what we did is we implemented a new diffing engine for the syntax tree of ERB. And the API for this is quite simple. So you can give it the old source, the new source, and it will give you the minimal amount of operations needed to go from one to the other. It's quite complex how it's implemented under the hood. If you want to check out the PR, it's all here. But the gist of it is that when you kind of take a tag, have a different output, the herb engine can tell you that the text changed in this case, from this text to this text. It also works for other things, like if you have this template, you add the attributes, it knows that you have a attribute added, and not just like some content change, but it knows we just added an attribute in this case. No white space differences, whatever. We know semantically it's only an attribute. This works for all the content, for HTML ERB, for all of that, and you can see where this might be going now. So we want to build a herb dev server too. So you have hot reloading in development. You can run herb dev locally. Whenever you do this, it will go through all your files, it will parse them, it will index them, and whenever it's ready, it opens a WebSocket server locally, and it uses kind of herb diff under the hoods to go from the old version to the new version. It diffs it, and then it can kind of output what changed as a result. So whenever you have these updates, it will log what changed in between. So this is the foundation, but what we can do now is put this in our proc file log locally, so we can run the herb dev server locally. And whenever you then have the web tools, the debug tools in your browser, it can connect to this web server locally using the WebSocket port. And this allows us now to go into our editor, change the templates, and whenever you change template, it immediately reflects it on the page as a result. This also works for partials. So when you have the same partial on the same page multiple times, you update the partial, and it kind of instantly updates on the right side in the browser. If you introduce syntax errors, it can now also show this right away. And whenever you fix them, they will pop away and just resolve. So you have this immediate feedback for just working on your files and then going back and forth. Without having to refresh the page, just the incremental updates, and that's kind of the idea. I have some bonuses here because you have some compile time optimizations as a result of that, because most of these were pretty much just side effects of working on this reactivity to make reactivity work, but they help with performance as well. So the first one was this for action with tag helpers, because we are able to turn it from this to this kind of syntax. We can now compile this part instead of the upper part, and this is obviously more performant because we do less work in Ruby, so we just can do more stuff statically. And there are some early benchmarks with this, so take them with a grain of salt, but we were able to see, in some cases, up to 150 times improvements for some mostly static content, but also up to 3 times to 20 times faster on more accurate real pages. And that's already really good, but we need to kind of see how this actually affects production in the end, but it's at least a good foundation just to see what we are working with. The other thing we were looking at were render call optimizations. So the most expensive operation in today's ERB templates are the render partial calls. And ActionView itself defines our templates as methods internally. But what we can do now, instead of doing this lookup for the partials every time we try to render a partial, we can rewrite this to actually use the optimized, or just the compiled output method. And then it's obviously much faster because it doesn't have to do lookup every time you try to render this page. So yeah, there's a lot of ideas here and a lot of kind of improvements. So some of them are almost too good to be true, but we need to see how this is going to affect production. But there's some performance to be gained somewhere in between here. But yeah, to conclude, I hope this has given you an overview of herb and its potential and how we are trying to achieve this reactivity in ERB. I think the Prism parse itself had a big effect on the Ruby internals and all the tooling in Ruby. And I believe that herb itself can have a similar effect in HTML templating and tooling. Also, more recently, we just saw GitHub adopting herb in their code base for all their 10,000 plus view files. So this is really exciting. So this is kind of the success that I want to share, that it's kind of taking off, and seeing people like GitHub or companies like GitHub adopting this is really great to see. So yeah, that's what I have for today. Everything I showed today is shipping in herb 0.10. It ships with the herb diffing engine, with the herb def commands, the herb action view command, and the CLI, these def server, and all these render graph analysis, static analysis, and these compartment optimizations. So yeah, with the herb toolchain as a foundation, I think reactivity now feels doable. I think it's the missing piece for the Hotwire story to make it perfect, so that we can keep writing Ruby and build more ambitious web applications with even less complexity. And these primitives now are what we need to ship a reaction view in the future, and that's kind of the idea. Finally, I want to give some acknowledgements to all the people that have been using herb and reporting issues, to all the contributors, and to all the GitHub sponsors that have been supporting this work over the past few years. So I want to give a big thanks to them. And finally, I also want to give a thanks to the GEM Fellowship Program, which gave me a grant to work on these reactivity features in herb. So yeah, thank you to all of you. Thank you for trying the tools. Please give them a try. Report any issues if you have, or give feedback. Give it a star on GitHub, and check out herbtools.dev on the website. Thank you so much.